Okay, so now that we have learned how to read a subscript in a chemical formula and what chemical formulas mean, today we're going to look at how to read a chemical formula containing coefficients. So that is our topic. Now, you're probably asking yourself, first off, what is a coefficient? Good question. Let's write that down. What is a coefficient? Okay, so what is a coefficient? A coefficient is a big number is the big number that is placed in front of a compound or molecule to show how many of that molecule are present. Okay, so it's the coefficient's a big number in front of a molecule, and it shows us how many of the molecule are present in the formula. So for example, let's do H2O. Well, we already know how to read this. We know that the subscript 2 corresponds with our number of hydrogen. But let's say we see something like this. Instead of just H2O, we see a 3 in front of the H2O. So this 3 now is our coefficient. So what does it mean? It means you have 3 H2O molecules. Not just one of them, you have 3 of them. So in essence, it means 3 H2O. So let's think about this. This would literally mean you've got H2O 3 times. That's exactly what it means. Now, since the chemist doesn't want to write out H2O 3 times, he puts a coefficient in front of the molecule to show how many are present. So now we don't have to write it all out either in order to figure out how many elements or how many atoms of each element are present. We're going to just do the math, okay? So a coefficient is used just like we use them in math. In other words, the 3 is going to be kind of multiplied by the formula that follows it. So let's look at that. How are we going to do that? So since it means this, we can check ourselves. So we're looking for how many elements are in this molecule. Well, there are 2, right? Which 2? There's hydrogen and oxygen. So those are the elements present. How many atoms of hydrogen are there? Well, if I look over here, I can see 2, 4, 6. So I know I've got to come up with 6. In this instant, we're going to take our coefficient and multiply it by whatever is present in the molecule. So we know we got 2 hydrogen here, so we're going to say 3 times 2. I'm going to multiply. So 3 times 2 is, yeah, you got it, 6. Now we only have one oxygen here, and I know it's one because there's no coefficient here. So if there were two or more, there'd have to be a coefficient. There's only one oxygen. So I'm going to multiply 3 times 1 is 3. So how many oxygen do I have now? I know that oxygen is equal to 3 atoms. And if you look here, that checks out as well. We had 2, 4, 6, correct, and 1, 2, 3, correct. So we don't have to write it this way, and that's why the chemist uses a coefficient to make it simpler. So let's practice some more. Let's do this. Let's say you have, this is practice now. Let's see, you have 4 molecules of iron oxide or rust, Fe2O3. Okay, remember, we know that that 4 means there's 4 molecules of rust, 4 of these, right? Or 4 times Fe2O3, right? So that's exactly what we're going to do. So we're going to count the elements. So what elements are present here? Well, there are 2 elements, right? And they are iron and oxygen. Okay. How many atoms? Well, if you look at Fe, we know that if we're looking here, Fe or iron had 2 atoms in the molecule, and we know oxygen has 3. So we have 2 molecules of iron, but our coefficient says we've got 4 of this whole thing. So we're going to, once again, we're going to multiply out. So we want to know 4 times 2, right? So for iron, we're going to have 8 atoms. And then we're going to do 4 times our 3, because we had 3 oxygen, but it says we have 4 of this whole thing, so 4 times 3 is 12, so O is equal to 12. Remember, you multiply. Okay, so our total count, how many atoms total do we have? Well, we have 12. We have plus 8 is 20 total. All right, let's practice again. Let's do one more together, and then y'all can work on some independent practice. But let's do one more together. Let's do H2O2, hydrogen peroxide. And let's say we have 6 of these. So our coefficient is 6. We know that according to our subscripts, we have 2 hydrogen and 2 oxygen present in hydrogen peroxide, and we have 6 of these. Okay, so we need to multiply out. So we're going to say, okay, 6 times whatever is here, and 6 times whatever is here. So elements, what elements are present? How many? 2. What are they? Hydrogen and oxygen. Good job. The atoms. How many hydrogen do we have? Well, we had 2. We have a coefficient of 6, as we have 6 times this. So 6 times 2 is 12, so we have 12 hydrogen. And oxygen was also 2 in the original formula, but we have 6 of them. So it is now 6 times 2 is also 12. So we have 12 atoms of hydrogen and 12 atoms of oxygen present in 6 molecules of H2O2. So total atoms would be 24 total. Okay, before we move on to independent practice, I want to let you know that we're building up to looking at chemical equations, and what you need to know is when you're seeing subscripts and coefficients, for example, in a chemical equation, let's say there's 2H2O plus O2 yields, and I'm not really worried about you looking at this right now or understanding this. We'll get there. We're heading there. But we know these subscripts only go with the elements that are right directly in front of them. But we also know that this coefficient only describes the molecule directly behind it. So if you reach a sign of any sort, then the coefficient no longer applies. There's no coefficient here. It doesn't have one. So if we were looking here, we would say, for this water molecule, there are 2 of them. The coefficient tells me there are 2 water molecules here. So I would know how many hydrogen are there. Well, 2 times 2, that makes 4. How many oxygen are there? 1, right? There's no subscript, meaning just 1, times 2 would be 2. And over here, after the plus sign, we have oxygen equal to 2. So coefficient only goes with the molecule directly following it. If you reach a sign or anything else, you're done with that coefficient. All right, if you have any questions, let me know.